This lesson is Introduction to Polynomials and Adding and Subtracting Polynomials. The beauty of this is that there's not a whole lot of application going on. You just have to know how to manipulate, and it's awesome. A polynomial in X is the sum of the terms of the form ax to the n, where a is a real number, 7, a half, 2/3, and n is a whole number exponent, okay? So which of the following are polynomials? Well, this first one is because we have numbers in front, and we also have whole number exponents. You're like, well, there's no exponent here. It's really like x to the 0, and x to the 0 is 1, and whole numbers start with the number 0. So this is a polynomial. This one is not, because we do not have a whole number exponent. 3/2 is not a whole number. This guy is no, not a polynomial, because I have x in the denominator. And if I were to rewrite that, it would be 2x to the -3. And -3 is not a whole number exponent. And this guy is okay. It's a polynomial. The numbers in front can be fractions, but the exponents can't be fractions. They can only be whole numbers, and the exponent is 1 on the x and 3 on the x there. The coefficient is the number in front of each variable term. If there's no variable, it's a constant. The coefficient is the number itself. A term is the product of the variable and the coefficients, just everything multiplied together. The degree of a term in one variable is the exponent of the term. The degree of a polynomial is the greatest degree of any term in the polynomial. So we're going to list the terms, determine the coefficients, determine the degree of each term, and then determine the degree of the polynomial. So in this first one here, the terms I'm just going to list down. Terms are separated by addition or subtraction sign. The coefficient is 2 on this one, 3 on this one, -1 on that one, and 1. The degree of this guy is the exponent, the exponent, the exponent, no exponent. The degree will be 0. The degree of the entire polynomial is the highest exponent in its degree, 3. Now you're thinking, why do we need to know this? Well, degree has a lot to do with how the polynomial, if it is set equal to y, is graphed, how many hills and valleys, things like that. Next, let's list the terms in B. It's nice and straightforward, you guys. We love that. The coefficient is 5, -4, and 2. Degree is 6, 4, and 1. So the degree of the polynomial is 6. It's the highest exponent in the problem. Now let's talk about types of polynomials. We have a monomial, which means that it's exactly one term. Binomial is 2 terms. Trinomial is 3 terms. So this first 3a will be a trinomial. 3b is a monomial. Mono means 1. Tri means 3. C is just a plain old polynomial. And D is a binomial. Now we're going to be combining like terms. Like terms are terms that contain exactly the same variables raised to exactly the same exponents. So for number 4, we're going to be combining like terms. 3x squared and negative 5x squared are like. This guy is different because he has a y in it. So we're just going to be combining this. So I have 3 pieces of paper with x squared written on it, and I owe you 5 pieces of paper with x squared written on it. So when I combine this, I get a negative 2x squared, and 2y squared just comes down like that. You can't combine those other ones. Now let's take a look at this. Let's circle the like terms. 3y and 5y is 8y. Take away 4x. Okay, let's take a look at this guy. This guy is like to this guy, and notice how I'm pulling the signs in. This guy is alike to this guy. So let's do our circle ones first. I have 2 of them. I take away 10 of them. I have negative 8 of them. I owe you 1. I owe you 5. I owe you 6. Notice how the exponents never change when you're adding or subtracting, but the numbers in front, or the coefficients, do. All right, let's check this one out. This guy and this guy, and no way for him, and this guy stands alone too, like the cheese. Let's combine the squiggly guys. 14a cubed b squared minus a squared plus 3b squared. Done. Now we're going to write the polynomial in descending degree order. That means I want it to be highest to lowest degree. So with no missing powers. So this guy is first. So it's x to the 4th. There's no x cubed, so we're going to write 0x cubed. No x squared, so we're going to write 0x squared. Ooh, there's an x to the 1st power, and then take away 7. Cool. Now we are going to evaluate the polynomial. So we're going to put in negative 1 for x. So I'm going to write the original polynomial, and everywhere I see an x, I'm going to put in like a little nutshell where the negative 1 gets all cozy in there. So negative 1 is 1. Negative 1 to the 4th is 1, because negative 1 times negative 1 is 1, times negative 1 is negative 1, times negative 1 is positive 1. 1 plus 4, take away 7. Left to right, 5 take away 7 is a negative 2. On to the next. Polynomials in several variables differ in determining the degree of each term. The degree of a term is the sum of the exponents on the variables. So here we go. Again, we're going to list the term, list the coefficient, list the degrees, and then determine the degree of the polynomial. So 2x cubed y, 3x squared, negative xy, and 1. Well, the coefficients are the numbers in front. That was not bad. The degree of this first guy would be a total of 4. Degree of the second guy is normal 2. Degree of this guy would be 2 because you add up those exponents, and the degree of the constant is 0. So the degree of the entire polynomial is 4, the highest degree in the list. Let's do the next one. Write the terms. Coefficients, 5, negative 4, and 2. Degree, add those exponents. add those exponents. Oh, this guy only has one exponent. Okay, so the degree of the entire polynomial is the highest degree in the list, and it is 8. Now we're going to add the polynomials. So we're just going to combine like terms. So you're like, well, look at these little parentheses. Don't panic about the parentheses. We're just going to rock and roll through it. Adding is a piece of cake. Let's combine the like terms. This guy's alike to this guy. This guy is alike to this guy. This guy is alike to this guy. And then last but not least, I'll use a circle. Let's go. 2x cubed, 3x cubed, 5x cubed. 3x squared, take away 1x squared, 2x squared. Negative 1x plus 3x is 2x. Positive 1, take away 1, zippo, so we don't even have to write it. Done. Next one says find the sum of this. Again, combine like terms. This guy alike to this guy, might as well add them up, 4x cubed. Then, this guy is alike to this guy, so if I add them up, I get 2x. Negative 2x squared is all alone, so I'm just going to write him down. And then finally, 10 take away 1 is a positive 9. Normally, we rewrite these in descending degree order, so it would be 4x cubed minus 2x squared plus 2x plus 9. Now let's subtracting. Just add the opposite. So this is important. I'm going to write down the first guy. The second guy, I'm going to change that subtraction to adding the opposite of this entire thing. So negative 3x cubed, positive x squared, negative 3x, positive 1. And then I can add. It's so cool. Change the subtraction to adding, and everything in that second polynomial changes to the opposite. And then we're right back to adding. This guy alike to this guy, negative x cubed. This guy alike to this guy, 4x squared. This guy alike to this guy, negative 4x. And last but not least, 1 and 1, 2. Done. Now, B is tricky. You have to write the problem out first. We're subtracting this guy from this guy, so the from guy goes first. So it's going to be x cubed plus 3x, take away 8, minus that big chunky monkey. So here we go. We keep the first guy the same. Change subtraction to addition, and the rest of it to its opposite. Combine like terms. Negative 1x cubed minus 3x squared, because he's the only x squared, so I combined my x cubed. He's the only 3x squared. Total of 4 x's, right? Him and him. Negative 8 and negative 1 is a negative 9-arino. Awesome. One more. First, we need to distribute and then combine like terms. So we get 5a plus 4b minus 3c. I'm going to distribute that negative 3 through. Negative 6a plus 27b minus 9c. So are we happy? Of course we are. We have a negative 1a. There they are. Foomp. Foomp. What about the b's? Foomp. Foop. 31 of them. What about the C's? Negative 12C. Now, you can leave it as negative 1A, or you can just write it as negative A. Notice how I changed the signs, I distributed, I tried to be very careful about my signs. Now you're able to do the assignment associated with this lesson. It's nice and breezy and quick. Take care and do the math.